Okay, so I am going to go ahead and get started. So the first thing that I would like to do is kind of go over some of what our goals are today. So again, the first thing I'd like to kind of remind you is that when you do sign in, please do not sign out and come back in right now, but you want to sign in with your first and your last name and then the school, because we're trying to get more of a collaboration between teachers and offer a lot more live lessons. So today the assignment is 8.07, Exploring Graphs of Polynomials. Okay, so you should have printed out the handout that was electronically sent to you. That was 8.07. Okay, also you should have paper. You can use the back of that to take additional notes. If you need collaboration credit, okay, so how do you know if you need collaboration credit? Well, you go to your grade book. I might have some segment 1 people in here, but I think I mostly have segment 2. But you go to your grade book and you see if you have 6.10 graded yet. If you don't, then you do need collaboration. If you're in segment 1, then that collaboration would be 1.10. Remember, you only need to do 1 per segment. I do want to emphasize that the collaboration and assignment 8.07 are 2 completely different assignments, okay? And they must be uploaded under separate assignments in your course. All right? Okay, so again, I am going to be monitoring the chat box. So if you have any questions as we're going along, please put it in there. And also, you must stay for the entire lesson. I am going to be taking attendance in a little bit, and I'm going to say it's going to be about an hour, okay? So just give yourself that, all right? I'm going to move along as quickly as I can, though. Again, I want to thank you so much for coming to this live lesson tonight. Okay, so again, just reviewing that you have to print out and save the Word document. In order to get credit for this assignment, you need to take a clear digital picture of it or scan it and then upload it for submission, okay? Now, if you are watching this as a pre-recorded live lesson, you cannot use this assignment as collaboration unless you've attended the live lesson or if you work with another student. Remember, the collaboration template, which I'm going to hand out electronically at the end of this lesson, is different than the handout for 8.07. Okay, so just kind of re-emphasizing that. Okay, so this is what we are going to be doing today. So you are all now officially members of the roller coaster crew. Okay, so our friends Ray and Kelsey, they have a summer internship at an engineering firm. That sounds awesome. As part of their internship, they get to assist in the planning of a brand new roller coaster. For this assignment, you helped Ray and Kelsey as they tackle the math behind some simple curves in the coaster's track. Okay, so the first thing I would love to hear from you guys is if you like roller coasters, please put a green check mark. If you don't, please put a red X. So under your name are the 4 boxes, and I want to either see if you love roller coasters or you don't like them. Okay, there are 4 other people in the class, so please go ahead and vote. Okay, I'm going to vote too. Okay, so everybody should be using their check marks. That is underneath your name. Oh, wow, we're about evenly. Oh, somebody changed their mind. Oh, my goodness. Okay, so at first somebody thought that they liked it and then they didn't. Okay, so we're about evenly split here. Let me see. Taylor, can you vote, Taylor? I want to know if you like roller coasters or not. Taylor, are you there? Okay, I'm not seeing. Okay. I'm not seeing anything. It can be a baby roller coaster. All right. So let's just see here if, thank you, Taylor. If you like roller coasters, can you please, in the chat box, you have chat capability, can you put what the name of your favorite roller coaster is? So in the chat box, if you can put yours, I went ahead and put mine. It's the Blue Streak. That's the name of my favorite roller coaster. I actually named my bike the Blue Streak. So in the chat box, if you can go ahead and put the name of your favorite roller coaster. Hollywood Rip Ride Rocket. Fun, fun. I do love roller coasters. Blue Streak is in Ohio. I am from Ohio, which means I love you guys so much that I'm missing watching my beloved Cleveland Indians play their 2nd game in the World Series tonight. The Hulk, that's a great one too. Okay, super. Thank you so much for that. And let us move on. Okay, so this is part A. The first part of Ray and Kelsey's roller coaster is a curved pattern that can be represented by a polynomial function. You don't have to write this, okay? This is your first question on your handout. They're working to graph a third-degree polynomial function that represents the first pattern in the coaster plan. Ray says the third-degree polynomial has 4 intercepts. Kelsey says, no, Ray, that's not right. It can have as many as 3 zeros only. Is there a way for the both of them to be correct? Explain your answer by typing in the chat box. If you have mic capability, you may use it. And you know what? I want everybody to answer. So if you don't know or you want to take a stab at why you think Ray thinks 4 or Kelsey thinks 3, or you don't know, just put question marks. Okay, they can both be correct. Zeros are x-intercepts. Oh, Rays are y-intercepts. I'm loving my answers here. Bravo. Okay, and if you don't know, again, the way I run my classroom is that, the way I run my classroom is that we're all kind of figuring this out together. So, you know, there's no, I mean, if you put something in the chat box and it's incorrect, no big deal. Okay, so let's talk about this. So first of all, Ray says that there are 4 intercepts. So let's take a look. So there's 1 intercept, 2 intercept, 3 intercepts, and then he is counting the y-intercept as well. And then Kelsey says, well, there are only 3 zeros. A 0 is where it crosses the x-intersection. So they're both correct because Ray was counting the y-intercept, 0, 6, and Kelsey was counting just the zeros, which are also called solutions. Okay? I'm going to go ahead and scroll forward because, again, reiterating, Kelsey's correct that the maximum number of zeros for a polynomial equals the degree of the polynomial. That is what is called the fundamental theorem of algebra, okay? So that kind of sounds very fancy, and let's talk about that. So, fundamental theorem of algebra. Okay, fundamental, and you don't have to write this down. Theorem of algebra states that if we have a function and the highest degree is a 5, there are going to be 5 solutions. Okay? If there's a 4, there's going to be 4 solutions. Okay? So that's what the fundamental theorem of algebra is. Okay? All right, so again, when we were talking about Ray, then Ray was counting the y-intercept. And y-intercept is important, and we're going to talk about that. All right? So they were both right. Okay. This is question number 2. Kelsey has a list of possible functions. Okay, these are, notice that these are cubic. Everything to the 3rd degree is cubic. Please write that down in your notes. So pick one of the g of x, which are cubic functions below, and then describe to Kelsey the key features of g of x. So the key features are going to be end behavior, y-intercept, and zeros. So we are going to work with these 3 later. I just want to do an example for you first, okay? And before we do that, I want to review the concept of end behavior, okay? So let's talk about end behavior. So end behavior can talk about, we can discuss it when we're talking about any polynomial. And what we're really looking for is what's happening at the end of the function. When I say end of the function, it's almost like you're in an airplane and you're looking down at how this function is graphed and you're seeing what's happening at either end as you're going to negative infinity to positive infinity. Okay? And you're going to, in the x direction, you're going from negative infinity to positive infinity in the y direction. So let's kind of break this down a little bit and make it a little more clear. Okay, so this is what I want you to do. On your notes, I kind of want you to break this up into 4 sections, okay? Because these it's going to be one of these four cases that we have here. And what I like to do is I like to use a function that you're very familiar with. So y equals x, okay? That is this graph right here. Okay, that's the y equals x. So what we look for here is that we look right here to see if it's positive or negative, and then we look right here. There's kind of a hiding one here to see if that's even or odd. So this is a positive, odd. Okay, because there's a hiding one here, all right? So now the next one that I want to talk about, and I want you to write, is y equals negative x. Okay, so this is a negative, odd. And a negative odd is a negative slope, okay? And then the third case I want to talk about, and you should be very familiar with these functions, okay, and we kind of call them parent functions, is y equals x squared. So here we have positive, even. Okay, so I do want you to be writing this down, positive, even. Then we have, I bet you can all guess what this is going to be, it's negative x squared, which we have a negative, even. Okay? So a positive even looks like this, and a negative even is a quadratic or parabola going down. Okay, so it's like, okay, Ms. Collins, I don't get this. So how does this fit into end behavior? All right, well, let's take a look at what's happening with this end behavior. So the way that we describe this in your curriculum does is that this is left down. Okay, so here's the left. We read it from left to right, and then it's right up. I'm going to abbreviate that, okay? Now here you can see that this is left up, right down. Okay, this one is left up, right up. So sometimes we just say up, up, down, down, and this one would be left, down, right, down. Now, if you can remember these four cases, sorry, I didn't put my 4 here, you are so good to go on every single polynomial. So what if you were given something like this? F of x equals negative 28.2 x2 the fifth plus 12x squared minus 4, okay? And you said, oh, I want to know what the end behavior is of that. Wah! Well, what you need to do is you just need to look at your highest exponent. You need to just look at two things. That's negative, odd. Negative, odd. So we don't know what this graph exactly looks like, but we know that if we were in an airplane looking down on it, the end of it, okay? So we don't really know what's happening like all in here and here and here and here. But we know then that it's going to end up looking like this. Okay, because why? That's negative and odd. So this works for any polynomial for what the end behavior is. Okay, so again, 4 cases. They are parent functions of a line, positive and negative, and a quadratic, positive and negative. Okay? Can I have a green check mark if you are understanding what I'm trying to say here for end behavior? Green check mark. I know it kind of took a long time, but this is an important concept, and I kind of want you to be able to take this all the way through calculus. Okay? All right, super. We are moving on then. Okay, so let's go back to our original question that we had here. Kelsey has a list of possible functions, picking one of the g of x functions below, and those were the ones that I had listed before. And we're going to include the key features, which is end behavior, we just went over, the y-intercept, and the zeros. So what I want you to do is, I want you, because I'm not sure we're going to take the time to do all of the examples, but I want you to go through this with me as I'm doing this example. So this is not one of the ones that was on your worksheet. So we're going to work this one out together, okay? So this is number 2. So you do have room where it says, here's my example on your handout. So I want you to follow along closely because we're going to be talking about a lot of important concepts here, okay? So the first thing that I'm noticing, okay, is let's do end behavior. Okay, so I'm looking here, that's positive and that's odd. So I know positive and odd was my line. So I'm just going to sketch that. So I know then that my end behavior is left, down, right, up. Okay, so that's my end behavior. All right? So hopefully we're good there. Okay, so again, it was positive, odd. All right, and so that's a positive. So this was what I was kind of getting at, was this line right here. Okay, now, y-intercept. Okay, when we're doing the y-intercept, what you do is you make, please be writing these notes, all of your x's equal to 0. Okay, so that means that I come over here and that's 0 plus 0 minus 0, and that leaves us with this right here. So our ordered pair, okay, for our y-intercept is we made all of our x's 0, negative 48. Okay, so that's our y-intercept. So it's almost like we can just hide all of this stuff, like all of this we can hide because that's going to 0, and then it leaves us with negative 48. Okay? All right, let me make sure that I'm checking the chat box here. Okay, good to go. Okay, so now the zeros. All right, so this is where we're going to do a review of factoring. Okay, there's a lot of great stuff in this section. All right, so the first thing is when I factor, I'm counting 1, 2, 3, 4 terms. Okay. Hint, 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 big hint. 4 terms. You factor by grouping. Okay, that's what it's called. So I count 1, 2, 3, 4. Ding, 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 ding. In my head, y is equal to 0 quadrinomial. Okay. Yes, MJ, that looks fabulous. Okay, so we have 4 terms, so we're going to factor by grouping. Okay, so this is what I want you to do. So we're going to rewrite this. So I hope you're writing all of this. So I kind of use my, oops, that's 48. And I want to make sure that you can all see that that's a minus. Okay, so let's talk about this. When we are grouping, okay, when we are grouping, you want to group, 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 group. Notice I left the subtraction out right here, okay? So did everybody group and group on their paper? Hopefully you can. Now what you do then is you factor out your GCF, okay? So between these two, all right, so let me, hold on a second. So between those two, when I'm factoring out my GCF, I'm factoring out an x squared, because I know x squared goes into x cubed and it goes into 3x squared. So I'm factoring that out. So that leaves me with x plus 3. How can I check that? Well, if I distribute that, that's x cubed plus 3x squared, it checks, okay? Then I put a minus, okay? Now, between a 16x and a 48, it's 16 that is my greatest common factor. So then I put x. Now, this is very, very, very important. Most of us are tempted to put minus 3 here because you see a minus here. But remember, we have a negative. So a negative times a positive is going to give me this negative back. The other thing that I want you to understand is this factor should match this factor when we're factoring by grouping. Okay? So let me review that very important concept. We're factoring out a 16. So we have parentheses, we have x. It is not minus 3 because when we distribute, okay, it would be minus 16x, yes. Then a negative times a positive is minus 48. Okay, so now we're not done factoring it. This is important here. I want you to see how we get our factors. I call it like, I like to go to the gym. So I like to call it, we're barbelling this out. So we have that big barbell that we have the weights on it. So I come out here, I come out here, Here's my barbell of the factor. So there's a factor. Now this one and this one we bring as just 1. Okay? So here we have it factored. All right, now, then you want to ask yourself, is there any more factoring I can do? Well, right here is the difference of perfect squares. So could I have in the chat box, what does x squared minus 16 factor to? Okay, what does x squared minus 16 factor to? It should factor into 2. Because remember, according to the fundamental theorem of algebra, we should have 3 zeros because it's x to the 3rd. Okay, so let's just kind of talk and review here about the difference of perfect squares. So we know that this one is x plus 3. Okay, so what times what gives us x squared? It's x. We don't have a middle term here, so we know one has to be positive and one has to be negative. The square root of 16 is 4 and 4. Okay? So this is completely factored, but it wants to know the zeros. So when it asks for the zeros, what you do then, okay, what you do is you find, okay, you set x plus 4. Oh, I'm sorry, I didn't want to really put those in parentheses. You just do x plus 4 equals 0. So x equals negative 4. X minus 4 equals 0. You add 4. So x equals 4. And then we have x plus 3 equals 0. We subtract 3, and we get x equals negative 3. We have 3 zeros. What does this mean? It means where they cross the x-axis. Okay, those are our solutions. Okay, now I know I went through like a bazillion different concepts. Yes, no, you're going to go ahead and because you're at the live lesson, you are going ahead and you are writing these notes for number 2. Okay? That's what you're doing. All right. Okay, so let's just review here what we did. Seems like days ago that we did this. Yeah, we're going to do a different one. Okay, so or you can do a different one. So we talked about end behavior. So we knew that it was left down, right up because we had a positive odd. Okay, right here. The second thing we talked about was the y-intercept. So we set all of our x's 0, 0, 0. It leaves us with negative 48. Then we counted 1, 2, 3, 4 bells in our head. Ding, 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 ding. We're factoring by grouping. So I do parentheses, parentheses. I factor out my GCF and what I'm left with. Subtract my GCF and what I'm left with. I barbell out the x squared minus 16 and then the x plus 3. Always ask yourself, can I go one step further and factor? And yes, you can. Difference of perfect squares. I set each of the factors equal to 0. Wowza. Okay. Can I have a check mark if you understand now how to get these key features of g of x, end behavior, y-intercept, and zeros? If you have any questions, please put them in the chat box. Okay, so I am waiting for, we need one more person. Okay, so somebody is putting something in the chat box, so we will give that time. Okay, and while that chat box is happening, I'm going to go ahead and move on to the next slide. Oh, what do we do with the 3's again after we barbell it? Okay, great question. So what we do with that is we take out both of these. Okay, so here we have the x plus 3 and the x plus 3. So you're going to have 2 of them and they match, and that's what you want to do. You bring them out as just one single binomial. Okay? Binomial meaning 2 terms there. Okay. All right, so I am moving on. Okay, so These were the original questions that we had, okay? So Kelsey had a list of possible functions. Pick one of them. Here's another option, and here's another option. Now, what I want to do is we are all just going to do one of these. And what I want you to do is I want you to do number 2, okay? So I want you all to work on number 2. Okay, so on your paper, please do what the end behavior, the y-intercepts, and the zeros are. And then what I'm going to do is I'm going to go ahead and I'm going to give you whiteboard capability. I'm also going to give you mic capability. You can grab the mic and give answers, or you can, what I want you to do is don't use the pen though, because you guys don't have like a tablet, you just have your mouse, which kind of makes a mess. But what I want you to do then is use the chat box, which is the 4th one down, to enter text on the page. So if you get the answer, or when you get the answer for number 2, just go ahead and start typing in there or grabbing the mic. And rest assured, you will have the answers to all of these, okay? So again, no worries on right or wrong. We're here to figure it out. So I'm going to give you a couple minutes. I don't want to rush you here. But if you get the end behavior, go ahead and plop that up there. If you feel more comfortable putting in the chat box, you can do that. We are only doing number 2. And again, we're going over end behavior, y-intercept, and zeros. So if you were watching this as a pre-recorded live lesson, you can pick number 1 if you want. You can do number 3 or number 2, whatever you want, but I am going to need to see the work. Okay, I would love to see some answers going up here. You're going to force me to be doing all the work here. This is your chance to shine. Show the world how awesome algebra is. Yay! Love it. Love it, love it. Seeing the end behavior. Come on, you guys have to do y-intercept. Yay! It's not 18 though. It's a special, oh, there, almost. I know, there you go. Yay! Beautiful. Whoops. Okay. Well, somebody has you think you got the zeros, super. You can either, again, you know, if you're not agreeing with anything that you see up here, but we're going to go ahead and talk about this right now. So again, end behavior, positive, odd. So I just quick in my mind do that. So I know it's left, down, right, up. Beautiful. Okay, y-intercept. I make all of these x's 0. Bada bing. So the ordered pair would be 0, -18. So that's what I would do on my graph, okay? Zeros. Okay, just so you know, these are correct. Beautiful. Let's just do a quick review. Okay, that's okay. No problem. So let's go, this is correct, okay? So this is absolutely correct. So let's go ahead and just review factoring by grouping. And let me rewrite it because I kind of made a mess over there. All right, so we have x cubed plus 2x squared minus 9x minus 18. Okay, so this is going to kind of reinforce our concept here. Group, 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 group. I bring out my GCF. So between this term and this term, it's x squared. It's just so, they're not all going to be x plus 3. Oops, wait, I lied. That's an x plus 2. Whoops. Okay. And then here, I'm going to put the subtraction. That gives me 9, excuse me, oops, I'm factoring out a 9. 9, that gives me an x, and then it gives me a plus 2, okay? So, here we go, barbell. Oh, lifting this out of here, we're taking it out. There we go, x squared minus 9. Then we're bringing this out as one binomial. This factors difference of perfect squares. And when we set these all equal to 0, we get -3, 3, and -2. Bravo, algebra students. Fabulous. Give yourself a pat on the back. I'm giving you a virtual high five. Okay, so let's move on. So here are all the answers. Okay, so if you are doing this at home, all right, and watching this pre-record, well, everybody's doing it at home. Duh, Mrs. Collins, duh. Okay, or maybe not, maybe the library. Okay. Giving myself an out there. So anyway, here are the answers. So you can check your answers here. Okay? So moving on, because they can pause this later. Okay. So this next section then says create a graph of the polynomial function you selected from question 2. So I went to Desmos.com to create my graph. Please look in the chat box for the link to Desmos and the link to a video to watch how I did this. Okay? So what I'm going to do right now is I'm going to post that link in the chat box right now. Okay, now I don't want you to do anything with it yet because we're going to talk about this. Okay, I love Desmos too. Okay, so it's there in the chat box. Now, I am not going to have us watch this right now for time. Okay, I'm going to have us watch the next one. But basically what this is going to do, and I will show you what this is going to do. But again, the chat box is there. Remember, I am recording this. I posted on my Weebly site under the Algebra 1 tab, so you can go back and look and like fast forward and then click on that. Yeah, and then click on that link and then watch it on your own. Okay, so we're not going to take the time and do that right now. But Desmos is a fabulous graphing tool. You can use it for scatter plots and a bunch of other stuff as well. And I do want you to become familiar with this if you're going to continue in the online classroom. Okay, so basically, this is what Desmos does for us. Isn't that pretty? Okay, so if you remember, all right, what we had before, our function, let's just kind of do a quick review of this and see what it looks like here. So our function was g of x equals, and then it was x cubed plus, 3x squared minus 16x minus 48. Okay, so that was the g of x, the example that I gave. Now, what I want, yeah, we're doing the first one. We're doing the first example that I did, okay, my sample. Not if you're coming to the live lesson, Bakari. So if you are watching this as a pre-recorded, you have to do the graph and show me the graph. If you want to use your own graph paper, or just do a quick sketch of it, or use Desmos and insert it, you have to, okay? But if you are at the live lesson, that's the bonus. You do not have to do it. But if you are watching this pre-recorded, you do have to do the graph, okay? So let's take a look. And if you want to use this example, you can. Okay, so remember when we did this and we did factoring by grouping, we ended up with these factors, x minus 4, x plus 4, and then we had x plus 3. Okay, so when we did this at first, we talked about the end behavior. Remember we said left, down, right, up. So I want to show you, because most of us are visual learners, and so when you see this, you can see this is left down, and this is right up. And really, I would feel much better if when we graph this, we could see this, because that is what's there. This is going on forever, okay? So that's what the end behavior is, all right? Then we talked about our intercept. Remember, the intercept is when we made all of these equal to 0, so we ended up with 0, -48. Well, what do you know? Right there, 0, negative 48. Funny how that happens. Okay. Okay. Now let's. Okay, so when we're looking at the zeros, okay, so our zeros would be x equals 4, negative 4, and negative 3. So that's where it crosses the x-axis. So there's our 4, there's our negative 3, and there is our negative 4. Okay? So can I have a check mark if it makes sense what we figured out and what we're now seeing on our graph? So doesn't this look like a fun roller coaster? All the way up, bazing, all the way down, boom, all the way up. Okay? Oh, you don't think it looks it's not steep enough. Well, that would be fun to play around with and see like how you could make it steeper. Okay, boom. Okay, so that would be fun to see how you could change that this graph right here to make it steeper. Okay, so that is our cubic function. Okay, remember our cubic function, okay, was an x to the third. It had 3 solutions, 1, 2, 3. Okay, our cubic trinomial, or excuse me, our cubic polynomial. There were 4 terms when we started. Okay, great. Now, here's part B. Okay, so we're on question 4 right now. So we're on the second page of our handout. Okay, so this says we're going to be talking about a parabola. So the first time in our first example we had a degree of 2, but now we have a degree of, we had a degree of 3. Now we have a degree of 2. So that is a parabola. Another name for it also is a quadratic function. Okay? So that's with a degree of 2. So the thing, it says describe the direction of the parabola. Okay? So the direction is, if it's leading, okay, this is what we're doing. We're looking right here. If the leading coefficient is negative, it's going down. If the leading coefficient is positive, it's going up. Okay? So that's all they're asking us for that one. Okay? So here's my parabola. All right? So we know that it is going down then. So what we say, what we say is we say down, down. Okay? For that one. All right? Now, let's see. Then it says the y-intercepts. Okay, well, we've done this before. That goes to 0, that goes to 0, so we're left with this. So the y-intercept is 0, 12. Okay? And then it says the zeros. So again, we're back to factoring. Okay? Now, let's talk about factoring. Okay, so when we are factoring, the first thing you want to do is you want to ask yourself, is there a GCF that we can take out, a greatest common factor? So when I'm looking here, I see a 2, a 2, and a 12. And we want to factor out the negative because we want the rest of these the first term to be positive. So we factor out the negative 2. So that gives us from here, this term, it's x squared. From this term, again, now please be careful here, it's negative x, because a negative times a negative is a positive. And here, it's going to be minus 6, because a negative times a negative. Now, how do I quickly check this? I distribute, and I multiply, negative 2x squared plus 2x plus 12. So I always double check my factoring before I start. Now, you come here, and you ask yourself, oh, okay, well, can I factor this? Let's try. Okay, so let's try to factor this out. So we have, so let's do a quick review of factoring. What times what gives me x squared? X. Now, notice here, I look here next. That's a negative. The only way I can get a negative is to do a positive or a negative times a positive. Doesn't matter which one. I'll just do positive and negative. Okay, now, what I do here is I look to my inside term. Okay, I look to my inside term and I see that this is a negative. So the negative is going to trump this. Okay, so I need to come up with 2 factors, either 1 times 6, but something that either adds or subtracts up to a negative 1 here, or a 1. Well, I'm going to be using these. I'm going to use 2 and 3. I know my negative trumps everything, so I'm going to use the 3 there, and then I'm going to use the 2. Now, a lot of people don't like factoring in math because it's like not an exact science. You kind of try again, and that's why we use a pencil, okay? So no worries. So you just keep trying and erasing and seeing until you get it. So we can double check this by foiling. So let's do a quick review of foiling. Okay, yep, it's almost like a guess and check. So foiling is you do your first. That's my first. X times x is x squared. Then I do my outside, negative 3x. Then I do my inside, plus 2x. And then I do my last, which is 2 times negative 3, which is negative 6. I group all my like terms here. Then I multiply out. So I get negative 2x squared. Oh, oops. And then I did plus 2x plus 12, and that matches. Okay? So all of that to come up with our zeros. So if you come back here, okay, to where we factored, sorry, this is getting pretty messy here. Our two terms, or excuse me, our two factors are x plus 2 equals 0, so x equals negative 2. And x minus 3 equals 0, so x equals 3. Okay, so there's a term, there's a term. All right? Okay, so those are our zeros. So did we get everything? Yes. Direction of parabola. If it's a negative, it's going down, down. A positive, up, up. Y-intercept, make everything 0, and our zeros we factor. Okay, moving on. Okay, so the next thing here is it says the safety inspector notes that Ray also needs to plan for a vertical ladder. Okay, so a vertical ladder through the center. So what does that mean? Here's our parabola. We need a vertical ladder through the center. Okay? Parabolic shape for access to the coaster to perform safety reviews. Find the vertex and the equation for the axis of symmetry. Okay, so this is what we're going to do next. So axis of symmetry. Okay, so please write this on your notes. The way we solve for the x is x equals, yep, it's the x value of the vertex, and we can get that by doing negative b over 2a. This is really important. You need to memorize that. Okay, so let's go back to my example right here. Okay. And let's figure out what our axis of symmetry is. So it's going to be the x value, which is x equals negative b, or the opposite of b over 2a. So what does all this mean? This is a equals negative 2. B equals 2, and c equals 12. Okay, so that's also, you can remember that from the quadratic equation, okay? So let's just kind of sub in here. So I like to say the opposite of b, because if it was negative, we would change that. So the opposite of b, so we have negative 2 over, and then 2 times a, so that's negative 2 over negative 4, which is 1/2. Okay, so my axis of symmetry is x equals 1/2. So what does that mean? That means that in a parabola, if this is 1, that means that my axis of symmetry is at 1/2. Okay, this line, oh my gosh, that was scary, a line. X equals 1/2, okay? All right, now, how do we find how high that goes, okay? What you do is, once you get this, then beautiful, plug it in, sub in x into equation. Now this is everybody's favorite. We're going to be working with fractions. Okay, so what I'm going to do is I'm going to clear this page for a second because I need all the room I can get for fractions. Okay, so don't worry if you didn't get it. You can go back and watch it, but basically we need to know that x equals 1/2. Okay, so we're going to sub in that here and that here because we're going to solve for this, which is our y. Okay, all right, so negative 2, I'm just going to plug this in, 1/2 squared plus 2 times 1/2 plus 12. Vicari, I'm going to post it on my Weebly, my Mrs. Collins website, and under the Algebra 1 tab under 8.07, that's where it's going to be. Okay, great question. Vicari was wanting to know where you could watch it. I post all of these, okay? So let's go ahead and do the math here. So this is -2. Now, 1/2 times 1/2, with fractions we multiply across 1/4. Plus, now, please note that when I multiply 2 times 1, I have 2 in the numerator, and 1 times 2, I have 2. So this equals 1 plus 12. Okay, so let's simplify this then. So that is, now we have -2/4 plus 1 plus 12, which is -1/2 plus 1 plus 12. Okay, so the easiest way to probably do this is -1/2 plus 1 is +1/2 plus 12, which is 12.5, or you could put 12.5. Okay, so the vertex 1/2, and, or it was, sorry, it wasn't 1/2, it was -1/2, wasn't it? Oh no, it was 1/2. Hi, somebody has the mic, yay! I hear somebody. MJ, okay. It was -b. Let me double check if this was +1/2 or negative. So it was -2 over 2. Okay, it was positive. So it was 1/2, all right? And then it was 12.5, okay? So if we were going to plot that, we'd go over to 1/2, and we'd go up to 12.5. Let's say that that's 12.5. And we know that that's the maximum of our vertex, okay? All right. It was positive. Super. Thank you so much. Okay. So we are moving on here. Well, first of all, can I get a check mark? If you guys are understanding this, I feel like I'm like zooming here like the speed of a roller coaster. The big idea here is, remember, to find the vertex, x equals the opposite of b over 2a. Then to solve for the y, you sub in that, okay, to get your y. All right? Okay. I see some green check marks. Okay. I know, it's a lot. This lesson covers a ton. That's why you guys should be so happy that you're here. I'm so happy you're here. Okay, so let's move on to this. All right, so if we had more people, we would probably be breaking up into teams, but we're not going to do that. We're just, these again are the ones that we have talked about as far as parabolas go. So what you would be doing is you'd be talking about the direction of the parabola. Now notice that these are all negative, so they're all down. The y-intercept, so again, we make all of these x's equal to 0. So it would be 0, 12, 0, 6, 0, -20, and then you would factor these by taking out the GCS. So in this case, it's a 3, in this one it's a 2, in this one it's a 4. Then you'd keep on factoring until you got your zeros, okay? And I'm going to go ahead and here, so again, this is all the blanks here, and here are all the answers, okay? So if you want to check your work, you can. All right? And you know what? This would be a great review, too, if you want to check your work, because all the answers are here. All right, so when we do vertex, again, that's x equals -b over 2a. The axis of symmetry, or excuse me, the axis of symmetry is x equals -b over 2a. The vertex is the ordered pair that you get after you sub that in. Okay? So here is, please notice the difference then. See the vertex and the axis of symmetry, the x values are the same. And then you sub in these x values and you get your y values for where you plot the, in all of these cases, it's the maximum because, again, we have a parabola that kind of goes down, okay? All right, so here's question 6. You want to create a graph of the polynomial function. Again, I use Desmos. What I'm going to do is I'm going to go ahead and I am going to show you what I did in this particular one, this Desmos. I went ahead and, hold on a second, edit, paste, okay. I went ahead and I showed you not only how to graph the parabola, but I showed you how to put these two together. Okay? So I'm going to go ahead and show that to you now, but it takes about 4 minutes and 52 seconds, but we're not going to take the time to do that now. So you will be able to watch it later. Okay, so here is, I used Desmos to create this graph. Okay, so again, let's take a look at where our zeros are. Okay, so that was -2, and then I forget what that ordered pair was. It looks like 3, and here we are at 12.5, and you can see our axis of symmetry here is about 1/2. Okay, so that is our parabola. Now, here's part C, and I'm doing this as a demonstration. Okay, so now that the curved pieces are determined, we're going to use those pieces as a section of a complete coaster. By hand or by using a drawing program, sketch a design. So if you are watching this as a pre-recorded live lesson, what I want you to kind of do is to go ahead and just sketch this on, it doesn't have to be perfect, just to kind of get an idea of what your particular roller coaster you want to look like. You don't have to include the coordinate plane. It's not going to be that exact, but I do want you to label it so we can see which one is the parabola, the function, and which one is the the cubic. So let's take a look here. So what I did is I just did screenshots of these, and I just kind of copy and pasted. Just so you know this, what you sometimes have to do is bring one of these pictures forward or back or stretch it. And so you can see here, you wouldn't really want to be on that roller coaster because look, there's a safety issue there. See how they don't quite meet up? That would be scary. But anyway, here's my roller coaster that I made, Bazumba. Okay, and that is what you do. You put these two together. Okay, so here you can see we have our cubic. All right, we have 3 zeros, and here we have our parabola. We don't exactly see where that is crossing, but we have our parabola, and we put them together. Okay, we are down the home stretch here. So here's part D. It's going to be, it drops like NASDAQ stock. Oh, you guys, I love live lessons because you guys are so bright and entertaining and funny. Okay, just the highlight of my day. Okay, so part D, we're going to create an ad campaign. Okay, yeah. So and to promote Ray and Kelsey's roller coaster. Now, again, if you're watching this as a pre-recorded live lesson, you can do a 15-second advertisement for television or radio. Oh, I've gotten some really fun ones. An interview for a magazine or a news report, a song, a poem, a slideshow. Somebody did a song. They played the guitar, okay, and they sang a song, they recorded it, and they uploaded it, which was so much fun for me. Okay, so these are just examples, so this is a chance for you to be creative in math class. Make sure to include a script of what you would say if you're preparing to interview or report. The purpose of this ad is to get everyone excited about the roller coaster. So this is what I would love for everybody who's in the live lesson to do right now, is I would like you to use the text box, and I want you to start to enter. Okay, so just start filling in adjectives. Okay, so we're going to kind of make our own ad now. Okay, so just go ahead and have at it. And we can have more than one name too, so please do. Okay, so you should all be typing right now. The text box is the 4th one down on your tools, and if you kind of drag it, and if you want to use the pen, it's going to be really hard to do with the mouse though. But if you want to use that pen to do it, go ahead. Let's go crazy. Okay, so I need to see, just start filling in. This is your chance to be English students in math class. Okay, so if somebody could start filling in, this coaster will make you feel blank and is better than any other coaster because you can't type in the text box. Then go ahead and use the pen. I mean, I've given you guys whiteboard privileges, so you can grab that pen and use your mouse to write stuff. Oh, coaster's going to make you feel nauseous. Oh, sometimes that happens. Okay, so we're going to give it one more minute. I kind of want to know why this roller coaster that you guys made is better than any other coaster. Maybe it's not. Okay, so we're going to spend about 30 more seconds doing this. I'm having so much fun. Wow, I'm like impressed that you're like word for word with this lines. Okay, so oh, that's funny. I love it. Okay, now, does anybody have the mic capability that has like a radio voice that wants to attempt to read this like it's an ad, like a commercial? If you do, grab it and go. I don't want to just be the only one hearing myself talk. Oh, no, it's not. My voice, I can hardly stand to hear my voice. Okay, so I'm going to, does anybody else want to take a stab at it before I do? Anybody with mic capability? Oh, Thomas, great. Okay, grab the mic. Oh, hey, Thomas, can you grab the mic? Just click talk. And then go for it. Read it. How are you doing, Thomas? Yeah, I can't hear him either, so it's not just me. Thomas, are you talking? Wow. Oh, I can't hear you. Do you have a mic on? Yeah, does anybody else want to try this? Okay. Looks like I'm stuck doing it. Okay. My new roller coaster. Well, MJ, do you want to try it in your British accent? Okay. Here we go. My new roller coaster is called the Red Rocket. It has giant, swirly, head-chucking, terrifying turns and flips and twists up and down, and then it drops. This roller coaster is better than any other coaster because this is made by algebra students. Yes, that's right, you, that have been taught by Mrs. Collins, who is the greatest teacher ever. Disclaimer, I did not write that. This coaster will make you feel nauseous, alive, terrified, better than your friends. It's godly, magnificent, glorious, and nightly after riding it. This is an awesome coaster, and you should all try it out. Okay. That was it. Hold on, let me go on here. Okay, let me go ahead and stop the recording.